All right, welcome everyone. Today we're putting on our detective hats and diving into a mystery that's literally planet-sized. It's a story written in stone, and it tells the incredible tale of life and death on Earth. So let's get right to our first clue. So take a look at this. Our first piece of evidence is this kind of strange, thin, light-colored layer of rock. Now, it might not look like much, but get this. This exact layer has been found all over the globe. We're talking Colorado, Italy, New Zealand, you name it. It's like a geological scar that marks a single, absolutely catastrophic moment in our planet's history. And this is where the real mystery begins. In the rock layers below this boundary, we find tons of dinosaur fossils, all kinds. But in the layers directly above it, they're just gone. Poof, vanished. So the question that's driven scientists nuts for decades is, what on earth happened right here? To solve a case this big, we first need to learn how to read the evidence. We have to learn the language of the rocks themselves. The easiest way to think about it is like this. Earth's crust is basically a giant history book. Each layer of rock is a different page. The oldest pages are way down at the bottom, and the newest ones are up at the top. And the fossils? Well, they're the words written on those pages, telling us exactly who was living and when. And wow, sometimes those words tell some incredible stories. On the right, this is a glyptodon. It's an extinct creature about the size of a Volkswagen Beetle. And this little guy on the left, that's its modern relative, the armadillo. It's through fossils just like this that we can draw a direct line from the ancient past to the animals we see all around us today. Okay, so to really understand how life can change so dramatically, we need to go back. I mean, way, way back. Let's rewind the tape to the very beginning of life's explosive story. Now, the scale of Earth's history is it's almost impossible to wrap your head around. For billions, with a B, of years, life was nothing more than super simple, single-celled organisms. Just look at this timeline. All of complex animal life, that includes us, everything we know, it all shows up in just the final sliver of time. We are a tiny, tiny blip. 3.5 billion years. Just let that sink in. That's how old our earliest direct evidence of life is. And it wasn't a bone or a shell, but the fossilized leftovers of microscopic bacteria. These ancient life forms were called cyanobacteria. They were microscopic powerhouses that grew in these layered mats called stromatolites, like the fossil you see here. And what's absolutely wild is that you can go to places like Shark Bay, Australia, right now and see living stromatolites forming in the exact same way. These tiny organisms are the unsung heroes of our story. They literally terraformed the planet by pumping our atmosphere full of oxygen, making all other complex life possible. Then, around 540 million years ago, something incredible happened. The fossil record just, boom, it burst with this huge variety of complex animal forms. This Cambrian explosion is where we see the first arthropods, the ancestors of insects and crabs, and where the basic body plans for almost all animal life that exists today were laid down. Life went from 0 to 60 real fast. So, how does life make these big leaps? Well, the key is finding what we call transitional fossils. Think of them as snapshots of evolution in action. Amazing evidence showing creatures with features of both an older group and its newer descendants. A super famous example is Tiktaalik, this fish whose fins had the bone structure of a wrist, showing us the very first wobbly steps of life crawling onto land. Okay, now buckle up for one of the most amazing evolutionary stories ever found in the fossil record. This is Pakicetus. It lived about 50 million years ago. It walked on 4 legs, and get this, it's the earliest known ancestor of modern whales. Yeah, whales. You heard me right. A few million years later, we meet Ambulocetus, which literally means walking whale, and you can see its legs are more like paddles now. It probably lived a life split between land and water, kind of like a crocodile does today. After that, we find Kuchakieticus, and the trend just keeps going. Its body is getting more streamlined, its legs are getting even shorter. It was a powerful swimmer, and by this point, it was clearly much happier in the water. The transition is picking up speed. By the time we get to Dorodon, around 40 million years ago, the transformation is pretty much complete. It was fully aquatic, its nostrils had moved up to the top of its head to become a blowhole, and its hind legs, well, they were just these tiny, useless little things. And here is the smoking gun. If you look inside a modern whale today, you will find the final piece of the puzzle. A tiny pair of pelvic bones, just floating there, not connected to anything. It's a crystal clear echo from the past, a relic of the legs its ancestors used to walk on land. How cool is that? But the story of life isn't just this slow, steady march forward. Nope. Sometimes the book of life has entire chapters violently ripped out. And that brings us to the idea of mass extinctions. We're not just talking about one or two species going extinct here. We're talking about global catastrophes, where huge percentages of all life on Earth get wiped out in what is, geologically speaking, the blink of an eye. This chart shows it perfectly. See that low bar? That's the normal background rate of extinction, a kind of steady hum of species coming and going. But a mass extinction, that's one of those dramatic spikes, a moment when the death rate just goes completely off the charts. What's really crucial to understand is that our planet has a history of these resets. There have been 5 of these massive extinction events. And look at the Permian-Triassic extinction, the one they called the Great Dying. It wiped out an estimated 96% of all marine species. Just try to imagine that. 96 out of every 100 species in the ocean. Just gone. Forever. And with this final piece of the puzzle, the idea of mass extinction, we can go all the way back to our original crime scene and finally solve the case of the disappearing dinosaurs. So remember this thin, light-colored layer of rock? It's not just a layer. It's the tombstone of an entire era. It marks the boundary of the Cretaceous-Paleogene, or KPG, mass extinction, which went down 65 million years ago. So, case closed. Here's what happened. We now know this event was caused by a devastating 1-2 punch. Massive volcanic eruptions were already choking the skies, and then a 6-mile-wide asteroid slammed into the Gulf of Mexico. It wiped out 70% of all species, including all the dinosaurs, except that is for one group that survived, the birds. And in the silent aftermath, with all the giants gone, our small furry ancestors found a whole new world of opportunity. And that leads us to one last, pretty wild thought. That single cataclysmic day, the day that ended the dinosaurs' 150 million year reign, was the direct beginning of our own story. Without that rock falling from the sky, the age of mammals might never have happened. Which leaves us with a final, huge question. Would any of us even be here to talk about it?